get some definitions out of the way first. Mitigation are efforts to reduce the amount of greenhouse gases being emitted into Earth's atmosphere, while adaptation is adapting to the inevitable changes in climate. Let's face it, even if we stopped all carbon emissions today, the lingering effects of the greenhouse gases we've already emitted into the atmosphere would continue to warm Earth's climate for the next 100 to 200 years at least. I really like this image on the screen because it shows a spectrum of actions that people can take to reduce their greenhouse gas emissions. On the left side are the lowest impactful actions we can take, and that includes replacing our incandescent light bulbs with energy efficient LED bulbs. It's easy to do, the bulbs are widely available in stores, and it makes everybody feel good about taking climate action. But the reality is it doesn't actually have much of an impact. The most impactful things we can do are all on the right side of the screen, and that's having fewer children. The reason having fewer children is the #1 most impactful action for climate change is that every single person who is born brings their own ecological footprint. They need land and water and air to process waste. They need land to grow food. They need space for infrastructure. They need water for drinking and bathing and food production. Those impacts last many, many years. The next most impactful things we can do is to live a life car-free, to avoid flying all over the place, to purchase our energy sources primarily from green sources such as wind, solar, hydro, and ocean sources. And we can also switch to a plant-based diet where we eat lower on the food chains or at lower trophic levels. Another way to mitigate climate change is to reduce the total amount of energy that we consume. We can do that by using the 3-tiered approach to pollution management, since greenhouse gases are in fact a form of pollution. Another Tier 2 approach to mitigating climate change is to improve the overall efficiency of the transportation that we use. We're not eliminating the greenhouse gas emissions entirely, we're simply limiting the amount that we release into the atmosphere by improved fuel efficiency. Another approach to mitigating climate change is to reduce the amount of greenhouse gases we emit into the atmosphere. And we can do that by shifting from individual vehicles to mass transit. So even though much of that mass transit may be releasing greenhouse gases, because we are using fewer vehicles, we have more people concentrated on the same vehicle, we are limiting the amount of greenhouse gases being emitted into the atmosphere. Let's not forget agriculture as a major source of greenhouse gas emissions. The cows, pigs, and chickens that people grow in order to eat are all undergoing respiration, and as a result, they release greenhouse gases. They release CO2, they also release methane, which is a powerful greenhouse gas in and of itself. Not only does the livestock that people produce release greenhouse gases, on large industrial farms, the mechanization that we use releases carbon dioxide as well, because most of those mechanized tools, the tractors, the harvesters, the combine machines, those tend to run on fossil fuels. And through internal combustion engines, they release carbon dioxide into the atmosphere as well. A great Tier 1 strategy for reducing our greenhouse gas emissions is to make the switch from fossil fuels to renewable sources of energy. As you can see from the graphic on the screen, about 3/4 of the world's energy sources are currently derived from fossil fuels. However, that slice of the pie dedicated to renewables continues to increase each year as the cost of producing electricity from renewable sources such as solar, wind, geothermal, hydroelectric, and ocean continues to fall, while the extraction cost of fossil fuels continues to increase. Just be careful when you're considering renewables, because not every renewable resource is a zero carbon or low carbon emitter. One of those hidden sources of carbon emissions in hydropower is the use of concrete to construct dams. Concrete is a very CO2 intensive material because of the production of the material and the breaking down of limestone based rocks where carbon in the form of calcium carbonate has been stored and locked away in a solid form for many millions of years. Geoengineering is another climate change mitigation strategy that people talk about for future generations. It's something that takes a very, very long time and involves the large-scale manipulation or change of global systems. Probably the easiest way to do this is through the process of afforestation, which is the opposite of deforestation. Afforestation means planting forests on a very large scale, because as those trees grow, they remove gaseous carbon from the atmosphere where it contributes to climate change, and they lock it into a solid form as biomass in their trunks, leaves, and roots. Afforestation is a great example of a carbon dioxide removal technique that protects and enhances our carbon sinks in Earth's atmospheric system. That's because forests extract carbon from the atmosphere and lock it away as biomass. If we keep the trees, we keep the carbon out of the atmosphere. Another great way to protect and enhance the carbon sinks on Earth is to focus our efforts at conserving the most biologically productive biomes on the planet. The dark green bands you see here focused around the equator, the Amazon rainforest in South America, the Congo Basin rainforest in Africa, and the tropical rainforest spread across Asia, represent the highest productivity levels on Earth. That means they are most rapidly taking carbon out of the atmosphere and locking it away into biomass, whether it's in the trees or in those nutrient cycles that happen as trees fall and decomposition happens, building up soil matter. One of the climate mitigation strategies that shows up in the syllabus is the idea of using biomass as a fuel source. And the reason that's considered a climate mitigation strategy that reduces greenhouse gas emissions into the atmosphere is because biomass is generally perceived as a renewable resource that can be replenished or replaced relatively quickly. I look at this graphic, and obviously the top parts of the graphic are fossil fuels. They're not biomass. The bottom three are considered biomass, and I'm skeptical of the use of lignite and peat as biomass as a climate mitigation strategy. Peat is undecomposed or partially decomposed biomass that has taken hundreds or sometimes thousands of years to accumulate. So that's carbon that has been slowly building up in a solid form over many, many years. And if we use it as a fuel source, we combust it and we release the carbon that's held in it or locked in it back into a gaseous form. The rate of replacement, the rate of release isn't quite the same as it is with fossil fuels that have been in the ground for 300 million years, but it is a significant difference. So tread carefully when considering peat as an alternative to fossil fuels. Growing crops to be used as a biomass for a fuel source could be considered a tier 2 strategy for climate change mitigation. That's because as plants grow, the process of photosynthesis pulls gaseous carbon out of the atmosphere and locks it into a solid form of biomass where it's no longer trapping heat and contributing to climate change. However, as you see in the cycle here on the screen, the transportation of those crops to a processing facility involve generally the release of additional greenhouse gases through the internal combustion engines of the vehicles. Now, the rate of replenishment of that biomass is quite rapid because crops can be grown annually or sometimes even twice a year. But there's a lot of debate about the net savings from growing crops as biomass for use as a fuel source. So don't consider this to be a guaranteed improvement for reducing greenhouse gases. Earlier, we looked at afforestation, the planting and growing of additional trees, forests on a large scale, as a climate change mitigation strategy because as trees grow, they extract carbon from the atmosphere and through the process of photosynthesis convert that gaseous carbon into a solid form as biomass in the plants. That's a geoengineering solution. Carbon capture and storage operates on a similar principle, but is generally considered to be an industrial process. So as you see in this image, we have a carbon capture and separation facility. And the idea is that CO2 will be pressurized from a gas form into a liquid form and pumped deep underground. In theory, that sounds great because you're taking gaseous carbon out of the atmosphere and putting it underground in a solid or a liquid form where it cannot trap infrared radiation and serve as a greenhouse gas. However, one of the things that liquefaction process